So we can see therefore that as the angle is getting bigger, what you have is you have a circumstance down here where here you see is 0 degrees, 30 degrees is slightly bigger, and this we now know we can compute as 1 because we found that it was 1 over 2, so there's the 1 of the opposite and the 2 of the hypotenuse. This we can now recognize as 1.4, and notice again, because it's 45 degrees, it has gone up, this height is 1.4, and this should continue, of course it's not to scale, it should be slightly higher, and this continues in this vein to the degree that, for example, for 60 degrees, we know it is root 3 over 2, and so what you have is you have 30 degrees, 45 degrees, 60 degrees, and finally 90 degrees. And what is 90 degrees? Well, 90 degrees represents, we've gone from 1 here to root 2 here, it's gone up, to root 3 here, and notice the opposite side is getting bigger, the hypotenuse side stays the same. The hypotenuse side is always this length here, is always 2. It is 2, 2, mother, it is 2, right? So what you have is you could, in these circumstances, you see that all my heights are 2 and my opposite are getting bigger and bigger and bigger. In fact, it goes from, by the time it gets to 90 degrees, so this length here, then the opposite side is 2 as well as the hypotenuse. So the opposite equals 2 at this point because it's maxed out. It's reached the maximum point that it can. And the hypotenuse is 2 at this point, meaning that we end up with 2 over 2, which means the sine theta value would be 2 divided by 2 is 1. That's what we say, the sine theta value here is 1. Now let's also consider cos theta. So in cos theta terms, what does this mean? How do we also aid to remember it? For cos theta, what I would do is let's have a quick recap that cos theta is the adjacent divided by hypotenuse, not the opposite. And when I say the adjacent, I'm suggesting to you that it is this length that we're looking at now. That is our adjacent side. And so for now, we do the same thing to aid in memory, divide by 2, divide by 2, divide by 2, divide by 2, divide by 2. However, this time I'm going to go the opposite direction, and you can consider the reason as to this as we go forward in the tutorial, and always also just to play around with the concept. Why is it that this structure works in terms of being easy to remember and also producing the correct solutions for the heights or the ratio between opposite and hypotenuse? We have, this one is for adjacent and hypotenuse, and as a result it goes root 0, root 1, root 2, root 3, root 4, which we can suggest, in my opinion, that is relatively easy to recall, such that you could do it with mental math rather than a calculator, or at least increase your probability of noticing a mistake and have a better understanding as to the structure of the adjacent side relative to the hypotenuse side for a certain angle theta.